Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. The reaction of a 1,3-diol with formaldehyde, HCHO, under acid catalysis, TSOH, heat, forms a 1,3-dioxane, 6-membered cyclic acetal, via condensation. The methylene, CH2, from HCHO bridges the two oxygen atoms of the diol. Moving on to the next step. The starting material is CH3CH, of CH, CH2PH, CH2O. The two hydroxyl groups are on C1, the CH2O end, and C2, the CH, O, bearing the methyl group, separated by one carbon, the CH bearing the benzyl group. Wait, let us re-examine. The structure is OCH2CH, CH2PH, CH, O, CH3. The two OH groups are on C1 and C3 of the chain, counting from CH2O end, making this a 1,3-diol. C1 is equal to CH2O, C2 is equal to CH, CH2PH, C3 is equal to CH, O, CH3. Moving on to the next step. HCHO reacts with the 1,3-diol to form a 1,3-dioxane ring. The formaldehyde carbon becomes C2 of the dioxane ring, the acetyl carbon, OCH2O. The two oxygens from the diol become O1 and O3 of the ring. And for the final step, the 6-membered 1,3-dioxane ring is formed as OCH2O connected to C1 from CH2O. So this ring carbon has two H's. Actually it contributes a CH2 to the ring, and C3 from CH, or CH3, contributing a CH with CH3. The C2 of the original chain, bearing CH2PH, becomes C4 or C5 of the dioxane ring. The dioxane ring carbons, position 2 is the acetyl CH2, from HCHO, positions 4 and 6 bear the substituents from the diol carbons. Specifically, C4 bears CH2PH and C5 bears CH3, from the original C2 and C3 of the diol. This gives a 1,3-dioxane with CH3 on one ring carbon and CH2PH on an adjacent ring carbon. Option B shows a 1,3-dioxane ring with CH3 on one ring carbon and CH2PH on the adjacent ring carbon, which matches the expected product. Why other options fail? Option A shows pH directly on the ring, not CH2PH, which would require loss of a CH2 group. Incorrect. Option C shows an exocyclic CH3 pH group, implying both methyl and phenyl are on the same exocyclic carbon, does not match the starting material connectivity. Option D shows pH directly on the ring adjacent to CH3, again pH not CH2PH. Incorrect. Therefore, the correct answer is B. Therefore, the correct answer is option B.